Okay, kids, we're going to see how this works. I hope you're all doing well. Everybody here in the Wenner household's doing great. A little strange these times, but everything's good. I hope you guys are well as well. And I miss you. Life's not quite as funny without you guys around. So here we go. So these are extra examples. You saw Coach Rudolph's video previous to this and copy out those notes. I just wanted to give you a few more examples so that you can feel more confident trying to do the practice problems. So here's the first thing. They're asking you for these parametric curves to find dy over dx. In other words, find the derivative. So what is dy over dt? And what is dx over dt? So you just take the derivative of each thing. So I'm looking at the y. If I take the derivative of that, that's 3t squared. If I take the derivative of x, that's 2t. And then all I have to do is divide them to get dy over dx. So dy over dx is going to equal 3t squared over 2t. And then you simplify it, t's can cancel, so you get 3t over 2. And then I say, all right, well, that's cool, but now figure out what the equation is for the tangent line at the point 1, 1. So let's keep going with this. This is telling us the slope. Dy over dx is the slope. You need a slope at a point. So my slope is 3t over 2, as we said, and we know that we've got to figure out what the t value is for this. So I've got to stop for a minute, because all I know is that x equals 1 and y equals 1, and I'm like, I don't know what t is to be able to figure out what that slope would be. So if I go back to the equations that they give me originally, x equals t squared, I know that if x is 1, then that would mean 1 equals t squared. And if y is 1 into the y function, it would be y equals t cubed. 1 equals t cubed. All right, so let's figure that out. If I take the square root of 1, I get t is plus or minus 1. And if I take the cube root of 1, I only get 1. So it's the one where they match. So I know that t has to equal 1 because that's where they both match. Which then helps me figure out what the slope is. So this would be 3 times 1. T value of 1 over 2, or 3 halves. And I need a point, so here comes the point. If I know that t equals 1, then I know that x equals 1 squared, or 1. And actually they gave me the point, really, I don't have to do this, I can verify it. And if I get my y cubed is 1 as well. We have the coordinate that matches, we're in good shape. Let's put the tangent line together. Tangent is y minus y1, which is 1, equals the slope of 3 halves times x minus x1, which is 1. Okay. All right, there you go. Equations of tangent lines, dy over dx's. Then they get into this crazy thing, and you probably saw this on Rudolph's video. Oh, by the way, I emailed him before I put all this together because I was asking him what book he uses, and he emailed me right back. It was very exciting. I told him that we all really love his videos, and he was very humbled, he said. So anyway, we talked to Rudolph. This is the part that's kind of confusing, the second derivative. So here's all the notation that you saw him giving you as well, and you probably said, what on earth is he talking about? So I put it into 3 easy steps for us. So you're going to find dy over dx. Well, that's what you just did back up in number 1. If you look at number 2, then you're going to figure out the derivative of that. That's going to be your numerator. That's this piece right here. And then you put it over dx over dt. So if I want to find the second derivative for this particular problem, I'm going to go to what I said was the first derivative. So I'm going to take step 1 and I'm going to start with what's dy over dx. Well, in this particular problem, you had to figure that out previously, and you found that to be 3t over 2. Step 2 says, all right, now take the derivative of that. So the derivative of dy over dx equals just 3 halves. And part 3 says, all right, well then put it together in your fraction. This is the numerator, number 2. Number 3 is the denominator, and the denominator comes from dx over dt. You found that back at the top of the page to be 2x. So number 3, I'm going to put it over here, puts it all together. My numerator is 3 over 2, this answer. My denominator is dx over dt, which is at the top of the page, to be 2t. Oh, we don't like complex fractions, so we're going to make it horizontal. So 3 halves divided by 2t. means that it's 3/2 times 1 over 2t, which means it's 3 over 4t. And what did you know that t was? You know, because we figured it out in part B, that t is 1. And that means my second derivative is going to be 3 over 4 times 1, and that gives me 3/4. And you just found the second derivative. All right, if you try some more, we're going to change up the equations and look at some other problems. Here's our new equations. And we're going to see if we can use these to answer these questions. So I'm finding the equation of the tangent line. Again, you need a slope and you need a point to be able to do that. So if I want the slope, I'm thinking of derivatives. I'm going to first figure those out real quick. dx over dt, dy over dt, so that I can use those to set up what my dy over dx is. All right, derivative is 1 minus 2t for the x. Derivative of y is 1 minus 3t squared. Now if I put that together to figure out dy over dx, so that I can work on the slope for this thing, my slope is equal to dy over dx, which we know then is 1 minus 3t squared over 1 minus 2t. When t is 2, well, they gave me a t value for this, so that's awesome. I didn't have to do the extra work of finding that. So when t equals 2, what would that look like? 1 minus 3 times 2 squared over 1 minus 2 times 2. And I get 12. 1 minus 12 is negative 11. I get 4. 1 minus 4 is negative 3. Gives me 11/3. And I think that's great. So I got half my piece here, but then I need to figure out the other piece, which is the point. So to figure out the point, I need an x value and I need a y value, but I know what x equation is, and I know what y's equation is, and I know what t is, so I can calculate that out pretty quick. If I plug a 2 in for my t's, I get 2 minus 2 squared for the x. I get 2 minus 2 cubed for the y. Negative 4, 2 minus 4 is a negative 2. This would be 8, it's negative. 2 minus 8 is negative 6. And so now I have a point that's negative 2, negative 6, and I have a slope that is 11/3. Here comes my tangent line. Tangent's going to be y plus 6 equals 11/3 x plus 2. And you just calculated out that tangent line pretty quick. Now the second part, part B, is, all right, find the second derivative and determine the concavity. Oh, they're adding an extra piece into this of the curve when t is 2. All right, so remember our steps. Step number 1, it takes my first derivative, my dy over dx. So I know dy over dx from the work I just did up above, 1 minus 3t squared over 1 minus 2t. And I need to, number 2, take the derivative of that. Oh my goodness. So if I take the derivative of 1 minus 3t squared over 1 minus 2t, that means I have to Hody-High. So we got to remember how to Hody-High this thing. This is going to take a little bit of work. So if I Ho, I am 1 minus 2t d-high times negative 6t, negative 6t. Thank you for erasable pens. Okay, minus the top, 1 minus 3t squared, times the derivative of the bottom, negative 2, all over the bottom squared. So I want to see if I can kind of simplify that a bit. Negative 6t times 1 is a negative 6t. Negative 6t times negative 2t is positive 12t squared. I have negative 2 times 1 is negative 2, but there's a negative in front, so it's plus 2. Negative 3t squared times negative 2 is positive 6t squared with a negative, so negative 6t squared. All over 1 minus 2t quantity squared. Can I make it any prettier? And I can. So here I go. I have 12t squared minus 6t squared is a 6t squared. I have negative 6t plus 2 all over 1 minus 2t quantity squared. There you go for step 2. Well, step 3 says, all right, we'll take that lovely thing and put it over dx. Well, dx back up here is 1 minus 2t. If I put it over that, it's going to be that whole crazy complex fraction thing. So I'm going to go horizontal. It's 6t squared. I'm over here looking at this. minus 6t plus 2 divided by 1 minus 2t squared, quantity squared, divided by dx over dt, which is 1 minus 2t. Now what's going to happen with that is you're going to change it. If you're dividing by it, you've got to multiply by its reciprocal, and that's going to put it back down here and add one more power to this, because it would be like multiplying by 1 over 1 minus 2t, which adds a whole nother grouping to your denominator. So my final answer for my second derivative is 2t squared minus 6t plus 2 over the quantity 1 minus 2t cubed. Now I can figure out what that value actually is because they told me when t equals 2. So now I'm going to put that into play here. That's my second derivative. They told me when t equals 2 they want to know what it is. So I'm going to plug a 2 in. 6 times 2 squared minus 6 times 2 plus 2 all over 1 minus 2 times 2 quantity cubed. So I got 24 minus 12 plus 2 is 14. The bottom is 4. 1 minus 4 is negative 3, and negative 3 cubed is negative 27. All right, so there's my value for the second derivative, and then it says determine the concavity of it. Well, concavity comes from second derivatives, and you just figured out it to be a negative second derivative. So we know that this must be concave down because the second derivative is negative. So that's a really easy question when they put that in there. You probably originally were thinking, oh my goodness, they're asking me so much. But it really is pretty easy once you find that second derivative. It's just, is it positive or negative? All right, the last thing that Rudolph talked about was when is it horizontal and when is it vertical tangent line. So if I'm looking at this last little bit here, there were some rules he said, and I typed them out for you here. When dy over dt is equal to 0 and dx over dt is not, that creates a horizontal tangent line. If you have dx over dt equaling 0 and dy over dt not equaling 0, then it's vertical. And he gave you some quick examples of this, but I just want to take you one more time through it. So you want to know when dy over dt equals 0. So I'm going to do that. Dy over dt equals, well, back up above, we said dy over dt was 1 minus 3t squared. I want to set that equal to 0 and solve it for t. All right, so I'm going to swing the things back and forth and make it 3t squared equals 1. Divide it. T squared is 1/3. And square root it. Now when I square root it, I get plus or minus the square root of 1/3. So if you go to your handy dandy calculator, these are going to be easier as calculator type questions. If you go to your calculator, this is going to be plus or minus 0.577. So if I look at the directions, find all the values for t, for which the graph has a horizontal tangent line and vertical tangent lines, then find the coordinates where that happens. So there's more to the problem than just finding the t value. Which, by the way, if I look at plus or minus 0.577, and I want to make sure that dx over dt is not equal to 0, all I need to do is take these t values and put them into the dx over dt function. I'll write it just here, just real quick, so you can see it all on the same screen. This is what it was. If I put this value in here, it's not going to equal 0. So I know that this second condition is taken care of when that dx over dt is not going to equal 0 at these t values. So just a real quick check for that. Then I'm going to take, if I've got two situations, t could either be positive 0.577 or negative 0.577. And so if it is, I've got two situations. If t equals a positive 0.577 and I put it into my equation, then it's going to be x equals 0.577 minus 0.577 squared. I'm going back to the original equations, right, because I'm looking for the point. I want to know what x is. So in the original equation, it was t minus t squared, and that's where I'm plugging it in. So if I do that, I'm going to get 0.244. If I put it into the y equation, then it's 0.577 minus 0.577 cubed. T minus t cubed was the original y equation. That comes out to be 0.385. And so I know that one of the points where this happens is at 0.244 when x is that, and y is 0.385. And then I'm going to do the whole thing all over again, if t equals a negative 0.577, and the work's going to be the same. Here's what I did in the calculator to make it a little easier. Let me show you. In my, can you see me? See if you can see me. Okay, so in my y1 I put x minus x squared, and in my y2 I put x minus x cubed. And then I just went to the table and I was able to get these values pretty quickly. So that was where I kind of calculated them out, and the easiest way I could find them. All right, so it comes out to be, when I do that, use your table, this one my x came out to be negative 0.91 and my y came out to be negative 0.385. So there's two places or 2 points where I've got a horizontal tangent line at those two coordinates. Now, second part is when it's vertical, so I'm going to do the same work, but I want to take dx over dt, and I want to set that equal to 0. Well, dx over dt from up above is 1 minus 2t. So I'm going to set that equal to 0. I end up with 1 equals 2t, and that means that t is 1/2. And so if I take a 1/2 and put it into the dy over dt, which is over here, if I put a 1/2 in here, I will not get 0 out. So the second condition is true. I'm okay to move on. So if I get a t value of 1/2, I need to figure out the coordinates again, what the x would be and what the y would be. They're going back into that same original thing, which is in your calculator. The x minus x squared, x minus x cubed. In other words, x is t. So when I plugged that in the calculator, I got an x value of 0.25 and a y value of 0.375. And so my coordinate where the vertical tangent happens is at 0.25 and 0.375. All right, hopefully that was helpful, and you should have enough information now to be able to work on the practice worksheet that is uploaded on our Google Classroom page. So let me know if you have any questions, and I miss you guys, and I'll talk to you soon. Bye.